Hello friends, welcome to the Tech Granth. Today I am presenting you another low level design video. So this video is on rate limiter, and the algorithm that we are going to implement in this low level design will be leaky bucket implementation. So if you are not familiar with what is a rate limiter, you can check out my video on the rate limiter. The link is there in the I button on top right hand side. So in that particular video, I have talked about what is a rate limiter, why do we need a rate limiter, and what are the various algorithms that we can use to implement rate limiter. So just to brief you up, so a rate limiter is basically used to restrict the number of calls to an API or to a service, and it can be implemented per user as well. So why do we need a rate limiter here is because it helps us to protect our API from abuse. For example, if you see this diagram, so we have a ticket booking service, and suppose someone is making a request. The person makes a request, it goes to load balancer and finally goes to ticket booking service. The ticket is booked for this particular person. Now suppose in place of this person a bot makes various requests, and what this bot does is it is just blocking the seat and it is not going ahead with the payment service. So if you have a basic idea about ticket booking service, you can check out the system design for ticket booking service as well on my channel. So link will be there on somewhere on the I button where we have the playlist for high level design. So what we do in case of ticket booking service is we block the ticket for certain or hold the seat for certain interval of time till the payment is made. So the duration, since the user had made the request and the payment is completed, that seat is held for that particular user. So suppose in place of that particular user, there is the bot who makes a request, and this bot has made multiple requests in parallel. So what will happen? It will block multiple seat, and it's not going to make the payment anyway. So the seat will be held for some time, and then it will be released. So in meanwhile, if some other user wants to book a particular seat which was held by the bot, then they will have a bad, basically they will have a bad experience on our website. So that is why we need a rate limiter, which will help our application to protect it from the abuse of bot or from an attack like DDoS. So that is one reason. Then it is cost effective, avoid cascading failure, and for security purpose also. So if you want to know detail about all these things, just check out the video on rate limiter. In this particular video, we are going to focus on the leaky bucket implementation. So I'm going to code it, and I will use Java as the language to code, and I will show you that how we can implement leaky bucket for rate limitation. So let's check the component that are involved. So first component or the first class that will create will be a rate limiter. So rate limiter can be an interface, and we can have a strategic pattern implementation if we want to implement multiple rate limiters. So suppose we want for certain kind of user we want token bucket, for certain we want sliding window, and for certain type of user we want leaky bucket. So we can have implement this strategically, and we can create rate limiter as a interface there. So this will the implementation of the rate limiter, what it will do is it will filter the request for us. And next uh, major component in the leaky bucket implementation will be the bucket creator. So we need a class which will create the bucket for us, and that bucket will be created per user. So let's look at the high level design of the class. So we'll have the application. The application will look into the bucket cache. So there will be a bucket cache where application can check whether the bucket was already created or not. If the bucket was already created, we can just use that bucket. Otherwise, we need to create the bucket. And this bucket creator will then call the rate limiter. And here the rate limiter will do its own action. If the application finds the bucket in the cache, then in that particular scenario, it will directly make a call to the rate limiter. Now, things to keep in mind here is that our system or the class that we create, it should be thread safe. Why it should be thread safe? Because multiple requests can come in parallel. So bot can basically originate the request in parallel, and our system should be able to handle it. And the next requirement will be that yes, it should be scalable. So the program that we write, it should be scalable, and we should have some feature, or at least we should be able to extend that program in a way that uh, uh, that if the system is in a distributed manner, so it should be able to scale up. So now let's jump into the code and see how we can implement this. As discussed before, first we will create our rate limiter. So that will be an interface. We will have a rate limiter here, and what this will do is it will return boolean, and let's say the method name is grant access. So this will basically grant access to the website or to the application that we are requesting, the user is requesting for. Now we need a implementation for this rate limiter, so we'll call it leaky bucket, because we are going to implement the leaky bucket implementation. So for leaky bucket, what we need is, so here what I'm going to use for leaky bucket implementation is a blocking queue. So why blocking queue? There are two major reasons why I'm going to use blocking queue here is, firstly, it basically says that, okay, if I have, suppose I have defined the bucket size as 10. So if the queue size goes above 10 in that particular scenario, it will fail the further request that is coming into the bucket. So that is one major reason, and that is what we want in a rate limiter. And second key thing is, this blocking queue, it is thread safe. So we don't have to worry about synchronizing it. It will be handled automatically. So what I'm going to do is, I'm going to use a blocking queue, and here I'm going to take simple integer. You can take your own Pojo class here. So we can say this is as queue. Let me expand it. This will be the blocking queue. Let us not initialize it. We'll initialize it in the constructor. And why we want to initialize it from the constructor is because I want to take the capacity. So what will be the capacity of the blocking queue from the user itself? So this will be new blocking queue of integer. Oops. Oh, sorry. The blocking queue is an interface. So it is implemented using a linked blocking queue or an array blocking queue. So I'm going to use linked blocking queue, and I will pass the capacity here. So we have the leaky bucket, this is ready. Next is, we need to implement the rate limiter here. So this implements rate limiter, and if we implement, we need to override the grant access method. So by default this will be false. Now how do we use this leaky bucket? Sorry, how do we use this blocking queue? So blocking queue has a method, it's called remaining. So if I say my queue dot the remaining capacity, if it is greater than 0, it means that the queue still has some capacity, and I will add queue dot add 1. Why I am adding 1 here is just because I'm accepting one request at a time. So if you think your request is coming as part of a bulk request or in block, so you can take an input here which will say number of request, and same thing you can add it in the queue here. But for simplicity, for now I will take the, I'll just assume that there is just one request that is coming per request. So in the queue I have added 1, and I will say, since I am able to add in the queue, I will return true. It means that I have the capacity to allow one request. So this is a simple implementation of leaky bucket class. Now next thing that we need to implement is the bucket creator. So here I will add another class which will be user bucket creator. So user bucket creator, what will be the input for user bucket creator? So one thing is, we need to identify each user by some specific field. So be it username, or maybe the IP address of that particular user, or something, we have to have some ID based on which we can identify, okay, this is the user from which the request is coming. So let me create another constructor for this, and here I will say I will take an ID as input, And what we need to do is, for each user I need to have a bucket. So I will use a map here. So this map will be a map of integer and leaky bucket. So this will be my bucket, and okay, let it be here, and we will initialize it in the constructor. So in constructor I will say that this bucket is equals to new hash map, and in bucket I can add my user. So I will add the ID, and I will add new leaky bucket, and we need to define the capacity. Now for each user, either I choose a capacity or I ask the application to configure it somewhere. So for simplicity I will simply hard code it here. So for each user I will define that the leaky bucket capacity will be of capacity 10. So once we have the bucket ready, then we need to delegate the action to the rate limiter. So here we can have another method which will be void, let's say, access application. So if it is able to access the application, then it will perform some activity, otherwise it will uh, throw some message. So, or it will throw back an error saying that there are too many requests. So what we need to do here is, if we have to access the application, then we have the bucket. The bucket will have the user ID, and for each user ID we have the leaky bucket. So here, to access the application, first I need to check whether the limit has been reached or not. So for that I will say bucket dot get, and I need to basically get the user ID. So I need to get the ID as input for me, so that when I access the application I need to check for which user I am going to access the application. So I will get the ID, and finally I will say grant access. I need to check whether the grant access method is returning true or false. So if the grant access method is returning true, it means I have the access to, I have the uh, bandwidth to allow one more request. So here I will simply print that able to access the application. Otherwise we can print. So from here we can return some, we can throw some error, or we can say that throw some error, maybe something like a 4 to 9 error, which means that there are too many requests. So I will simply print here, and I will say too many requests. Please try after some time. So what this means is that I already have a lot in my queue, and I'm not able to process everything. So I'm limiting you from accessing the application now. You try after some time. So this will be the access application code for me. Now, finally, what I need to do is, anyway, I'm returning false from here. So the bucket creator code is ready for me. Let us test this, whether this is working fine or not. So I will create an application. So for application I will have public static void main, and here what I need to do first is I need to create the user bucket. So I need user bucket creator. This is equals to new user bucket creator, and say the user ID is 1 for now. And once we have the user bucket creator, what I will do is I will run it in a loop. For int I is equals to 0, I less than 12, I plus plus. So user bucket creator, and I will say you access the application for user ID 1. Let us see what happens. And this is not yet complete, so we need to implement few more things before we go. But just now I want to show that what is going on currently. So what it does is, it has printed 1 2 3 4 5 6 7 8 9 10. So 10 time it is able to access. Last 2 time it is not able to access because there are too many requests. Now currently to my leaky bucket, this queue, there is no consumer to the queue. So everything that I am sending is still present in the queue. So in a real world application, what will happen that the queue will be processed also. So item will be picked up from the queue and it will be processed. That is one scenario. Now second scenario is that what we talked about is that it will not be a case in most of the time that there will be a serial kind of request. So the request will come to the application in parallel. So let us try that also. So to parallelize the application, I will use executor service. Executor service, I will say executors is equals to executors dot new fixed thread pool. I will say in 10 threads because we have 10, so let's say in 12 threads. So I want to run my application in 12 threads. So for that, and for those of you who are not familiar with executor service, this is just a way, or not familiar with Java also, so this is just a way to parallelize my application. So it will create 12 threads for me and it will run the application in parallel. So what I'm going to do is for 12, I will say that just copy this and you basically access the page for me. Okay, so nothing much here. Okay, now few things that we need to take care of. Actually, let us run this first and then we'll come to know. Okay, we are getting similar response. I did not stop the executor, so it did not came out. So what we need to do here is that we need to do a shutdown here, and what we can do is where we are printing this, I just want to print the thread name also. So thread dot current thread dot get name, and just to see from which thread the request is coming. So I will add this as well. So let us run this again. So if you see, there are multiple threads that is accessing this together. So for 10 threads, it is able to access the application. For the remaining 2 threads, it is not able to access the application because the request limit has reached. Now, if you see, the code looks very simple. It is working in a multi-threaded environment, but we did not do any synchronization or any hi-fi implementation. The reason being, the bucket creator, this bucket creator is not multi-threaded because each bucket will be created for one user. Once we have created the bucket, when we have to access the application, even this bucket will be one bucket. uh, Basically this bucket will be appended, one user, it will be appended one time only, or basically the value will be put one time only, and then it will be the leaky bucket part will be appended. Now leaky bucket that we have created, so this is implementing the blocking queue which is thread safe. So hence it is able to handle the change, because every time we are making any change in leaky bucket, we are basically modifying the queue which is linked blocking queue. So that is the whole reason why it is able to perform, it is able to work properly. Now this will work in a single instance scenario. What if we have a distributed system? What change that we need to make now? So if we have a distributed system, this application will run into multiple application server, and in each application server it will have its own queue and it will have its own bucket. Now the thing is, if each of them has a capacity of 10 and we have like 3 application server, so a user can make 30 requests, because each time the request can be redirected to one of the application server, and it is possible that or the 30 requests that the user has made has gone to has been distributed across the 3 application server. But we don't want that. We want the rate to be limited to 10 only, so that user is able to make only 10 requests. Once those 10 requests are processed, then only he should be able to make another 10 requests or so. So for that, what we can do is we need to make this bucket, and this basically leaky bucket for each user as a global instance. So to do that, what we can do is we can have a global distributed cache, something like Redis. So what we will do is this map or this bucket that we are creating in the local cache, this we should put it in the global cache. So when we put it here, rather than doing this, the same thing, we need to make a connection to the Redis and we need to put this in Redis. When we do this get operation, so we should get it from Redis. So that way, each of the application server, it will be talking to Redis, and we will have a centralized position where we will have a bucket for each user. So that way we can scale out this particular code as well. So one thing that is missing in this particular code is, since we have implemented the leaky bucket process, it is not constrained by time. So once the 10 request for a user is processed, the user is able to make another request. So if suppose our application is fast enough to process that particular user, but for some reason, like for example, say security reason. So if someone is typing some password, so first time the request goes, okay, the request has failed, so the user has retried. So again we want the user to retry the password. So if in parallel the user has made 10 requests for the password with some, because basically he's trying to hack the user ID of someone else. So 10 requests will be processed, and after that we will have the capacity to process another request for that particular user. So that is not good. So for that we need to limit the user based on time as well. So we don't want the user to attempt the password now another for another 24 hours. So once the 10 request is exhausted, so user should only retry password after 24 hours. So to do that, the algorithm that we are going to use is called token bucket. So in my next video I am going to implement the token bucket. So that is it for this video. Do like the video if you reached till here. Do put it in the comment section if I have missed something, or if this can be enhanced in a better way. So thanks for watching Tech Granth. Take care. Bye.